All right, let's go ahead and try out another one of these problems. Here we're going to be solving the 3x3 system. That's three equations with three variables. Here we have first equation, x1 minus 3x3 is equal to negative 2. Then we have 3x1 plus x2 minus 2x3 is equal to 5. And 2x1 plus 2x2 plus x3 is equal to 4. Once again, we're going to be using a Gauss-Jordan row reduction for this. As such, I would like to begin the process by converting to an augmented matrix. Here we have three equations, and we have a total of three variables plus an augment. These will refer to the coefficients of x1, x2, and x3, followed by what they're equal to. Now you'll notice in the case of the first equation, there is no x2 term. We can still come up with the appropriate coefficient for it, though, in the form of 0. So first row will be 1, 0, negative 3, augmented by negative 2. Second row will be 3, 1, negative 2, augmented by 5. And the third row will be 2, 2, 1, augmented by 4. Now normally the first thing that we would want to do is make sure that we have a 1 in the 1, 1 entry. That's already been taken care of for us. As such, our first goal in this case is going to be to get zeros in the two entries below that lead one. Now we're actually going to do this by only taking one step in which we do two operations. So to clear out the positive 3, we'll need the negative 3. So we'll take negative 3 times that lead 1 in row 1, add it to the second row, and that'll become the new second row. Then we'll do a similar thing with the first and third rows. We have a positive 2 there. We'll add to that negative 2 times the first row plus the third row. That'll become the new third row. Those two operations should give us the zeros that we desire. So overall, first row remains the same. 1, 0, negative 3, augmented by negative 2. Then we'll take negative 3 times 1, add to 3, we'll get 0. Negative 3 times 0, add to 1, we'll get 1. Negative 3 times negative 3, add to negative 2, we'll get positive 7. And finally, negative 3 times negative 2, that's 6, plus 5 is 11. Similar thing for the third row. Now we'll do at negative 2 times the first row. So negative 2 times 1, add to 2, we'll get the 0 that we wanted. We'll do negative 2 times 0, add to 2. Negative 2 times negative 3, and add to 1. That'll be positive 6 plus 1. And finally, negative 2 times negative 2, which is 4, add to 4, and we get 8. Ooh, cool. All right, now that we have the lead 1 in the first row, zeros below it, we're going to ignore the first row in the first column and just focus on this little 2x3 matrix right here. So first thing we want is a 1 in the 2, 2 entry, which we already have. What a present. Then we'll want to get zeros in the entry below it and above it. We already have one above it, so we'll just worry about the 0 that we want right below it. Now the way that we can obtain such a matrix is by taking, let's see, we have positive 2, we want negative 2 there. So we'll take negative 2 times the second row, add that to the third row, that'll become the new third row. So overall, the first row is staying the same. The second row is staying the same. And the third row is being altered. So taking negative 2 times the second row and adding to the third row. Negative 2 times 0, add to 0. This is why we like having zeros there. Negative 2 times 1, add to 2, we'll get 0. Negative 2 times 7, add to 7, that'll be negative 7. And negative 2 times 11 is negative 22, add to positive 8, that'll be negative 14. Now that we have our lead 1 in the second row with zeros above and below, now we ignore the second row and second column and just focus on this 1 by 2 matrix right here and getting that to row echelon form. We could do so very straightforwardly by taking negative 1/7 of the third row and making that the new third row. Basically, we would just want to turn this negative 7 into a positive 1. So again, 1, 0, negative 3, negative 2. 0, 1, 7, 11. Then we take negative 1/7 of 0, negative 1/7 of 7, and negative 1/7 of negative 14. At this point, we are now looking at row echelon form. We have our nice little staircase of lead ones with a bunch of zeros below it. However, if we wanted to take this to reduced row echelon form, that last lead one needs zeros above it. So we want 0 in this entry here and this entry here. We can obtain those zeros using two operations. Where we have a positive 7, we will need to add negative 7. So we'll take negative 7 times the third row, add it to the second row, and that'll become the new second row. To get rid of the negative 3 that's here, we'll need a positive 3. So we'll take positive 3 times the third row, add that to the first row, and that will become the new first row. So overall, the third row is staying the same. That already tells us what that variable is equal to. Then we'll take negative 7 times 0, add to 0. Negative 7 times 0, add to 1. Negative 7 times 1, add to 7. And negative 7 times 2, add to 11. It's negative 14 plus 11, that'll be negative 3. Then, up in the first row, we'll take 3 times 0, add to 1. 3 times 0, add to 0. And 3 times 1, add to negative 3. And finally, 3 times 2, which is 6, add to negative 2, we get 4. This is now reduced row echelon form, and we can interpret appropriately. So again, this is equation 1, equation 2, equation 3, coefficient of x1, coefficient of x2, coefficient of x3. Your first equation can be interpreted as 1x1 plus 0x2 plus 0x3 is equal to 4. The second equation is saying 0x1 plus 1x2 plus 0x3 is equal to negative 3. And the third equation is telling you 0x1 plus 0x2 plus 1x3 is equal to 2. Because we got one singular value for all three of these, we would describe this system as being consistent. Good stuff.